On the subject of mechanics of materials, a couple of very important concepts are those of stress and strain. What do we mean by stress and strain? Well, these have to do with the behavior of materials under loaded conditions. And stress is defined as force per unit area. Force per unit area would represent stress. The units would typically be things like pounds of force per inch squared or similar units, but very often it's written in terms of MPa. Now there are two kinds of stress. One is called a normal stress and the other is shear stress. And the names pretty much tell you how they're measured. With normal stress, we find that the force is applied to the surface area. So for instance, here is a piece of material, and if we were to apply a force normal to this area and causes some deformations or we cause some stress, we'll talk about the stress being force per unit area, then we're looking at, this would be what sigma represents. So sigma would be this force per unit area. Now in the case of shear, we're applying the force right parallel to the area. And so we define the shear stress as being tau, and tau is the ratio of the force parallel to the surface area divided by the surface area. Okay, so much for stress. Now the other important concept is strain. What do we mean by strain? Well, the strain, let us first define what is meant by linear strain. Linear strain is a change in length per unit length of the material or the member that we're working with. And this delta, let's suppose you had like a rod, and after you load it, it increases its length by some delta, and L is the total length approximately. So the ratio of the increase to the original length is called epsilon, and it's unitless. Sometimes it's written in terms of inches per inch or meter per meter, or sometimes no units at all. So that can be a little bit confusing at times, but in either case, epsilon is the change of length per unit length and is known as a linear strain. Now there's another kind of strain called a shear strain. See, over here we had normal and shear, now we have linear and shear. With the shear strain, we're talking now about an angular deformation resulting from shear stress. So we have in this case the situation where we would say gamma would represent the shear strain, and it's an angular deformation, and this can be written as the change delta parallel to the area, delta parallel to the area divided by the height. All right, we'll say more about these a little bit later, but right now let's go on to talk about a couple more important definitions.